Hi. So for today's demonstration, we're going to design a counter with mode control that cycles through the binary representation of 0 to 3 in decimal. There's a manual mode switch to determine the direction of the sequence. When mode is 0, it will count down like 0, 3, 2. And when mode is 1, it will count up like 0, 2, 3. There should be a synchronous clear switch to force start 0 at any time. We should use T flip-flops. So let's get started. Here I have the state diagram with two bit state here. The state A is 0, the state B is 2, the state C is 3. So when the mode is 1, it will go from A to B to C, and when the mode is 0, it will go from A to C to B to back to A. That's how this mode switch is going to work. And now we have the next state table here. So for the next state table, we have drawn the present state, next state, and the flip-flop inputs here. We basically went through the states here by going through 0, 0, and with the input of 0 or 1. And then mode 1, 0 with input of 0 and 1, and mode 1, 1 with input of 0 and 1. So the next state is going to switch to according to the state diagram. So if it's 0, 0 and mode is 0, it will go to C. If it's state 0, 0 and input is 1 on the mode switch, it will go to B, and so on the rest. We have the T flip-flop inputs as well here. And when the mode is 0 on the Q0 and the next state Q0, the flip-flop will not switch, and when it is 0, 1 or 1, 0, the flip-flop will toggle. So that's why we have this T flip-flop inputs here based off of the Q0 and the Q1s here. So we got all our T inputs. And the next, we derive the Boolean equation using Carnot maps. So for T0, we have this table right here, which derive this Boolean equation Q1 prime, Q0, or Q1 QX. And for T1, we have Q1 prime, Q0 prime and X prime, or Q0X. And we also have the outputs, which is Z1 is Q1 and Z0 is Q0 based off of the table here. And that's pretty much it. We got our diagram. Now we can build this circuit, build a circuit diagram in Logisim. So based off of the Boolean equation we see earlier, we built this Logisim circuit. Basically, the T0 is coming with the Q1 prime and a X prime ANDed, and that get ORed with the Q0, and that also get ORed with the Q1 and X ANDed together. And the T1 is just with Q0 prime and X prime, ORed with the Q1 prime, ORed with the Q0 and X. I use tunnel for this, so there are tunnels to simplify the wiring here. And now this circuit, in every clock sequence, when the mode is 0, it will go from 3 binary 1 1 to 2 binary 1 0 back to 0 0. And when mode is 1, it will go from the opposite. It will go from 2 3 and back to 0. That's pretty much it. The circuit is done and the circuit works.